Hello, I'm Steve Proctor. We'll talk for a few minutes about gauge blocks. Gauge blocks are actually length standards, best known for being able to be put together into various stacks of different sizes. We look at many different sets that'll have 81 pieces, upwards of 120 pieces, as low as down to 9 pieces, just depending on what the application is that a particular laboratory or inspection area is going to need. We look to gauge blocks to designate how long things are, make sure that we have a proper standard. We have several here in our set where we have a 4-inch gauge block with 2 precision surfaces and a hole down the center used for holding together when they're rung. You can slip rods between them and hold them together, not just depending on the ringing surfaces, which we'll get into in just a moment. What we're looking here is a precision surface that you don't want to touch with your bare hands on either end. Human skin oils will actually cause them to corrode and rust and cause all sorts of problems with them losing their accuracy. On top of all that, when handling gauge blocks, if you're not wearing gloves, you want to handle them as little as possible, just the tips of the fingers. The body heat that we have, as we'll transfer to it, will actually change the length of it a significant amount depending on the measurement you're trying to take with it. When you're looking to gauge blocks, being able to stack them together is what makes them so wonderful. Nobody in this set has a 1.5-inch block, but I needed a 1.5-inch setup. I'll take a 1-inch block, a 1/2-inch block, and I'll put them together. Before doing that, I'm going to clean all the storage oils off of them using a chamois, making sure that I get all the residue off of them. And then I'll ring them together very simply by placing one on top of the other, sliding into place with some pressure, and then turning so they make a single block. The great thing about gauge blocks is being able to ring them together to get a particular size that perhaps doesn't exist in the set. In this case, if I want to get a .585 block, I don't have that in this set, but I can take a .45 and a .135 and ring them together to make the same block. Take them together, push together, twist, and they actually do set up a nice little surface so that when I pick one block up, they'll both come together. This is going to be the result of a couple of things. One, pushing them together, I'm forcing the air out between, causing a slight molecular vacuum in between the blocks, so air pressure is going to hold them together, as well as just the properties of 2 extremely flat surfaces also cause some molecular cohesion, and so they stick together. They won't shake apart, they won't come apart as long as it's rung correctly. You can hold on to these all day long and they'll stay exactly as they are. You can create any combination size almost using just these gauge blocks. This 81-piece set can come up with thousands of combinations that any inspection lab or any quality lab is going to need to come up with. This would be especially useful when setting up indicators to check a dimension on a part, or even to set up a sign bar when looking to create a particular angle. When you're looking at a set of gauge blocks, there are several different grades of accuracy that we're looking for. Different sets, depending on when they were manufactured and to what standard they were manufactured to, are going to have different accuracies. You're going to want to look at the requirements of your measurement in order to determine which set you're going to use. The Fed spec set up the grades so that you would have grades such as 0.5, 1, 2, and 3, all going down so that the tolerances were wider as you went away from 0. You would have 3 used on shop floors, 2 used in inspection labs, 1s and 0.5s in calibration labs. More recently, there's been another standard written out that actually changes how they're done and how they're taken care of. They expanded the length tolerances, but made it a little more tighter on how they can vary across their surface for that length. So they're measured in more spots. And these grades are usually known as AS2, AS1, AS0, AS00, and then K for laboratory grade blocks. They are not nearly more accurate, but they are more consistent across their surfaces. All depends on what the requirements of your laboratory and your inspection processes are. When it comes to caring for your gauge blocks, one of the most important things is keeping moisture away from them. As you clean them, again, you're going to use a soft chamois so that you're not damaging the surface. But as you go to store them and put them away, you're going to want to coat them if they're stored in any length of time without being used in a light oil. Usually you can find Stare at M1 oil works very well, or any sort of oil that's going to protect it and keep it from being rusted. Also might recommend placing inside the box perhaps silica packets or Knox paper. This is going to help them last a whole lot longer and be a whole lot more useful. You'll also want to be careful not to drop them. Different materials of gauge blocks are going to react differently to being dropped. Stainless steel here, it will dent, can easily be lapped out to be taken care of and fixed, while something like chromium carbide, very hard but very brittle. It'll usually chip the corners off of. And if you are fortunate enough to be working with ceramics, the ceramic gauge block will rather break and very expensive to replace. You want to be very careful not to drop them. And as always, when you're handling them for more than just a few moments, you're going to want to use gloves. This again is going to protect them from the corrosive properties of your skin oils, and it's going to help keep them keep their temperature nice and even versus having to let them cool back down after you've handled them for quite some time.